at least one software-defined network, or VPC, right? So when I create my virtual machine, and let's just create one here, and as well as choosing the region, the zone, etc., the machine type, you'll see down here under networking, I've got to choose my my VPC that I want to connect to, right? So again, if I scroll down here, you'll see that the default is to connect me to the default VPC, right? So if I have a look at that, if I have other VPCs in my project, I can connect to those instead. In my case, I've got 2 VPCs, but in this case, I will connect to the default VPC, right? And I also have to think about whether I'm going to have an internal IP address only, or I'm going to have an internal and an external IP address, right? So the default is to have both, but often for security reasons, you do not want to have an external IP address, right? So, but let's just create one with both IP addresses. And you'll see that once that instance is created, it'll have both an internal IP address, and again, let's bring up our VPC here. So if we go into VPC, just say VPC. So if we go into VPC networks, and you'll see this is for my project. I've got 2 VPCs. Now, the default VPC is created automatically when the project is created. And if I click on that one, you'll see that that is made up of 40 subnets, right? So you'll see that I've effectively got a subnet for each region that Google Cloud is available in, right? And I've got an IP address range for each subnet, right? So you'll see this, of course, is only for the internal IP address, right? So if I go back and have a look at this instance here, you'll see this instance is in US Central. Because it's in US Central, I've been given an internal IP address out of the range for US Central. So you'll see here, US Central, the range of IP addresses is 10.128, right? So basically, whenever I create a VM on the default network and put it in US Central, I will get an IP address out of that range, right? If I choose another region like US West, I will get another range, right? Now, the external IP address, of course, that's unpredictable. That is just allocated out of a block that is available for Google, right? So public IP addresses are allocated differently from internal IP addresses, right? So internal IP addresses are sometimes called private IP addresses. External IP addresses are sometimes called public IP addresses. Why are they called that? Because I can connect to them from outside I can connect to them from the internet. That's why they're public, right? Okay, now I can also create, if I create another instance, I can do the same thing, but I can create another instance on a different VPC. So when I go down here and choose my network, I can remove the default network. And again, it's giving me a warning saying that a VM always needs to be connected to a VPC, but I'm going to choose a different VPC, my VPC. And again, you'll see it's got a different IP address range there. Right? So now I've got a second VM, which is in the same region and actually even in the same zone, I think, but it's on a different logical network. This one is on the my VPC network, which again, if we go back here, my VPC is what's called a custom VPC. So normally when I'm using VPCs, I don't use the default VPC because I can create a custom VPC and choose which regions I want to create address spaces in, right? So if I'm not going to be creating VMs in Europe, for example, why do I need a address space for Europe? So a custom VPC is where you as a customer choose which regions you are going to have address spaces for. So on this VPC, I've only got 2 regions, right? Whereas the default one, I've got 41, right? 41 subnets because I've got one for each region. Okay, so we've talked about VPCs and we've talked about internal and external IP addresses. Let's also talk about firewall rules. So firewall rules are controls on what traffic comes in and out of a VPC, right? So and again, they are generally applied at the individual VPC level. So you'll see these rules here are applied to the default VPC. These rules down here are applied to my VPC, which is my custom VPC, right? So generally firewall rules are applied to a single VPC, right? Now, again, let's just have a look at this allow HTTP rule, for example. And with any firewall rule, first of all, which VPC is it being applied to? Is it controlling incoming traffic or outgoing traffic, or ingress or egress? Is it an allow rule, or is it a deny rule? So an allow allows the traffic, a deny rule blocks the traffic. Source filter says, for this example here, basically I will accept HTTP requests from any IP address. That effectively means any IP address. And I will accept requests on port 80. So port 80 is what's called a well-known port, which is the ports that are you can identify traffic types by the ports that they use. So HTTP uses port 80, right? And it's also showing me that that this firewall rule is being applied to instance 1 that I created on my VPC just before, right? So this here is a little sanity check I can do to make sure that the firewall rule that I've created is affecting the instances that I expect. Okay, now the other thing that also gets generated for our firewall is if we should pin that VPC networks. So you'll see I also have routes, right? So routes are routing table entries that show me how I can move packets between different locations on my VPC. So let's say I go to US Central on my VPC. So that's telling me that when I send packets from this subnet, they can go into one of 3 places. First of all, if I'm talking to another virtual machine on my subnet, on the same subnet, I will use this route table entry here, right? If I'm talking to, and again, if I click on that, you'll see that route table got generated automatically, right? So that's basically going to route me to that packet there, to that subnet there, right? If my destination IP address is 192.168.3.0, then I'm going to use this route table entry. Anything else, because remember that's any other address, I will use the default route to go out to the internet, right? So generally route tables get generated automatically when you create your subnets in your VPC, right? Okay, so let's just pause there, see if there's any questions. Yes, generally the route table entries are created automatically when you add new subnets to your VPC, when you create your custom VPC, right? The only reason when you need to modify your route table entries is, for example, let's say I wanted my instances not to be able to communicate with the internet. Then I might remove this default internet gateway because this allows them to get out to the internet. But if I didn't want that, I could remove those route table entries, right? So I can, that would be a situation in which I can edit my route table entries. But generally they get created automatically as you add subnets, and that's generally sufficient. Okay, so let's go back and have a look at some slides. Now we've had a bit of a look in the console, right? So basically we're going to talk about a couple of things. First of all, what is a VPC? It's a software-defined network, right? So I mean, all the public cloud providers pretty much use software-defined networks, right? So it's a logical network that you can use to network your virtual machines, right? Now, the VPC, of course, is separate from the physical network that links all the Google Cloud regions, right? So if I have, I mean, for example, if I go back into my project, and you'll see that I've got a virtual machine in US Central on the default VPC. So if I create a second virtual machine on that VPC, and let's put it in a different location, let's put it in Europe. So let's just say put it in Finland, and we create that instance. And so you see instance 3 is going to be in Europe North, right? Now, if we have a look at the, so once that's created, you'll see that the IP address, the internal IP address, has been allocated out of the block for that region, right? So again, if we have a look here, you'll see Europe North 1. So that's why I got that particular IP address. But the point that I want to make here is if I connect to instance 2 or instance 1, which is on the default VPC, but it's in US Central. So if I just connect to that instance, and once that first connection goes through, that's just authorize the connection. Okay, so now if I ping the instance 3, now instance 3 is on the same VPC, but it's in Europe North, so it's tens of thousands of kilometers away. But you'll see that if I ping that IP address 10.166.0.12, you'll see that the response is very quick, just a little bit over 1/10 of a second, right? Even though it's tens of thousands of kilometers away. So the point is, how could it be so quick? Well, basically the answer to that is because it used the Google private network. So this private network is used to link all the different data centers. So US Central is here, so it went on the Google private network across to Europe into Finland, which is up here. Right? Okay, so most of these things, these are some of the VPC objects. We've talked about quite a few of them, things like networks, subnets, regions, zones, IP addresses, and routes and firewall rules. So remember, a VPC is made up of one or more subnets, and the subnet maps to a region, right? And within a region, I have multiple zones, but basically I have one subnet per region, not one subnet per zone, right? So basically the subnet is created for a region and applies to all zones in that region, right? And again, we have an IP address range, or what is called a CIDR range, for that's used for the internal IP address of the VM. So we saw that before, right? Okay, now when we create a subnet, we have different types, right? As I mentioned, the default subnet is created automatically when you create a new project, and that has one subnet for every Google Cloud region, all 41 of them, right? But normally you don't want to create VMs in every single region. So normally what you do is you create a custom VPC. So when you create a custom VPC, you choose which regions your network is going to be in and what the IP address ranges will be, right? Okay, and if we wanted to add a VPC, if we wanted to add a subnet, so let's say I was looking here and just say I, my VPC currently has two subnets, US Central and US West. But let's say I wanted to create a range for US East because I needed to create some VMs in US East. I could add a new subnet, right? So I could call this US East and I could choose the region and give the IP address range, right? Make sure that it's not currently in use, and then I can add that IP address range like so, right? So once I've done that, now my custom VPC has 3 regions rather than 2, right? So I can adjust the number of subnets as necessary. Right? And I can do that either through the console or through the command line interface. Right? Okay, now I can also expand the subnet, right? So basically to expand the subnet, you've got to modify the subnet mask, right? So if we have a look at an example here, so let's just go back and look at a subnet that we might want to expand. So let's go into default, and you can see that, for example, US East, my subnet mask is 20 bits long, right? So because my subnet mask is 20 bits long, that means if I have on my network, that means I have 2 to the power 12. So that's 32 minus 20. 2 to the power 12, which is 256. I think it's 2048, right? So I have 2048 addresses. Is that right? 2 to the 10 is 1024. Sorry, it's 4096 addresses, right? So let's let's say I need more addresses than that, right? So what I need to do is I need to reduce this to say 18. Then I have 14, 32 minus 18, and basically I have 16,384, right? So basically, by reducing the number of bits in the subnet mask, I expand the number of bits. I expand the number of addresses available on the subnet, right? So how do I do that? I can just go in and I can edit the subnet mask. So let's say, what did I say? I'm going to increase the number of addresses by 4 by reducing that, right? Now, again, if you, and again, the background knowledge here is there's a thing called CIDR addressing, right? So basically, that's how you calculate the number of addresses that you have available. Now, you don't have to, how can I say, you don't have to be an expert in CIDR addressing, but if you do want to understand the calculation that I just made, you can look up on YouTube or there's a lot of tutorials on explaining CIDR addressing. It's a little bit beyond the scope of what we're going to talk about, but if you do that, right? Okay, any subnets, any IP addresses? Yes, there are 4 addresses reserved, right? So actually, if you have, say, 8 bits for your host ID, you have 2 to the power 8, which is 256, but you have to take away 4 addresses, right? So again, if you Google that, okay, so basically you'll find that there are 4 IP addresses that are reserved. So there are 4, yes. Route table entries are generally created automatically. Is there any limited number to create? Is there any limited number to create the subnet in one VPC? Well, your maximum subnet mask is 28 bits. You can't have a subnet mask greater than 28 bits. So that is a minimum. Okay. Okay, and yes, the default routes generally will get generated automatically. Okay, so we can expand a subnet, and we can do that at the console as I explained to you, or you can do it with the expand IP range command at the one shown on your screen there. And you can also have in your subnet, you can also have the primary range, but you can also have secondary ranges as well, right? So this is optional. So when I'm looking at my subnets, so you'll see here I've got my subnet here. So again, if I just click on edit here, you see here I have the option to add a secondary IP address range, right? Now, why would you do this? This is often done when you are using Google Kubernetes engine, right? Because in Kubernetes, there's 3 kinds of things that need IP addresses, right? Nodes in the cluster, pods, which are a Kubernetes resource, and servers, right? Services, which are Kubernetes resources, right? So if I've got 3 kinds of things that need IP addresses, it makes sense to have separate IP ranges for each type of thing, right? So that would be an example where I might want to create secondary IP address ranges, right? Again, you'll see that it's automatically done when you use GKE, right? When you create a GKE cluster, right? Okay, so what about if we have multiple VPCs and we've got VMs on different VPCs? So what are the rules about VMs communicating with each other? So if the VMs are on the same VPC, they can communicate with their internal IP address. Even though they're in different regions, it doesn't matter, because think about what I showed you before when I had A was in US Central and B was in Finland. Because they're on the same VPC, I could communicate with their internal IP address, right? If the VMs are on different VPCs, even if they're in the same region, they have to communicate with their external IP address, right? So same network or same VPC, internal IP address is used. Different VPC, external IP address is used, right? Okay, there are also occasions when you might want to connect your virtual machine to multiple VPCs, not just one, right? So why would you want to do that? Because maybe the virtual machine is running some security software and you want to inspect the packets as they move between the two VPCs. It's not very commonly done, but it can be done, right? But every virtual machine must be connected to at least one VPC, right? You can't have a virtual machine that's not connected to a VPC. Okay, so we talked about traffic routes, right? So route table entries get generated automatically, and they move the packets between different subnets, right? Now, there are some use cases where you need to create static or manually create your routes, but generally speaking, they will be created automatically for you. Okay, so let me just see that. Would the default route be based on deny inbound traffic? Well, yes. Basically, the rule is on VPCs that unless I can find a rule granting the inbound traffic access, there is no access. So that is correct. The default assumption is to deny inbound traffic. That is correct. And what about public IP address? It's taken automatically. Yes, it's taken automatically. It's just allocated out of Google's block of public IP addresses. There is a thing called bring your own IP address, which is a customer can bring their own public IP address if they want to repurpose it in Google Cloud. But generally speaking, it is it's basically taken automatically, right? And there's also a cost for external IP addresses. There's no cost for internal IP addresses, right? Okay, now in terms of other networking costs, basically the thing to remember is that ingress, incoming traffic, is free. Egress, unless it's in the same zone, is charged, right? So you'll see if I've got egress between zones, it's going to be charged for. If I've got egress between regions, it's going to be charged for. So ingress is free. Egress, unless it's in the same zone or I'm talking to other Google Cloud services or products, egress between zones and egress between regions is charged for. Right? Okay, so here's the bring your own IP if you want to repurpose one of your public IP addresses. Right? Again, there's no charge for the use of this because after all, it is your IP address. So customers might do this if they want to. Let's say they had a service with a public IP address that was previously hosted on-prem. They want to move it into the cloud, but they want to use the same IP address for the service. That would be an example of that. Okay, so We can't create a VM unless we attach it to a VPC. That's the first rule. We talked about the default network is created when we enable the compute engine service, and that has a subnet for every region in Google Cloud. And remember, when we create a VM, we always have an internal IP address, but an external IP address is optional, right? VMs on the same VPC can communicate with internal IP addresses. VMs on different VPCs have to communicate via external IP address, unless peering is enabled, right, which we'll look at later. In fact, we can look at it now, right? So if you don't want a machine to be directly reachable from the internet, you don't give it an external IP address. Okay, so let's just have a look at peering before we look at anything else. Just see if there's any questions. What is deny inbound traffic? Well, basically, if I can't find a rule granting access to the inbound if let's say you're trying to connect to a virtual machine using HTTP, if there's no rule granting HTTP access to that VPC, you will not be allowed to do it, right? So that is what is meant deny inbound traffic, right? If there's no rule granting you access, you don't have access, right? So in security, that is called the assumption of no access, right? So in other words, if I can't find a rule granting you access, your traffic will not be allowed, right? Because I'm assuming no access. Right? Okay. Okay, so let's have a look at VPC peering, right? So let's have a look at our instances here. And what I'll do is I'll delete this one here on Europe North for a sec, just so you don't get confused. Okay, so you see I've got two instances here. Instance one is on the default VPC, and instance two is on the my VPC, right? On a different VPC, right? So if I go and connect here, I've lost my session, but let's just start it again. So remember, instance one is on default and instance two is on my VPC. So they're on different VPCs, right? So what did we say? We said that if they're on different VPCs, they have to communicate with their external IP address, right? So if so just let me clear that. So if I try and ping, I'm on instance one. If I try and ping instance two, I should be able to do it, right? Because I'm using the external IP address, and that's fine, right? But what about if I try the internal IP address, right? So if I try and ping instance two by internal IP address, remember they're on different VPCs, so this doesn't work, right? Because they're on different VPCs, I can't use internal IP address, right? Except if I use VPC peering. So if I peer the VPCs, so if we go here to peering, so peering is where we basically want to optimize the communication between two VPCs, because communicating via internal VPC is more efficient, right, than communicating by external IP, right? So we're going to peer the two VPCs, and basically we have to do it from both directions. We have to do a handshake, so to speak. So that's half of the relationship, but I'll now create the second half, going back the other way from my VPC to default. And we'll just take all the defaults here. And we'll refresh that. Okay, so now the peering relationship between the two VPCs is active. So now what I can do is I can go back and try that ping again, the one that failed, right? So because now the VPCs appeared, my ping now is successful, right? Now you might say, well, so what is the benefit of VPC peering? It's in communication via internal IP address is more efficient and more streamlined than external IP address. So if I want VMs to talk on different VPCs in the most efficient way with their internal IP address, I can use peering. Right? How many subnets can you create? Well, I don't know what the limit is, but generally you've only got 41 regions, but you can create multiple subnets per region. So, you know, who knows what the number is, but practically speaking, you generally would not create more than 40 because there's only 41 regions, right? Unless you had a special requirement for multiple subnets per region. Okay, so and again, you only create subnets for regions that you're going to create virtual machines in, right? So if you're creating virtual machines in 2 regions, you'll generally only have 2 subnets, one for each region, right? A lot of customers would only create virtual machines in a couple of regions, like 2 or 3, right? So they would typically have a VPC like this rather than the default VPC, which has a subnet for every region, right? That the only reason Google create that is to kind of idiot-proof it for people who are beginners, right? But generally, in a production environment, I would remove this default subnet. Right? Okay, so normally the scope of a VPC is scope to a single project, right? So if I go and have a look in this project here, I've got my VPC. But if I go to another project, if I go to my DevOps project, I've got different VPCs, right? So the scope of a normal VPC is to a single project. But if I have hundreds of projects, I don't want to have to manage hundreds of VPCs. So what I would like to do is have this concept of a shared VPC. So a shared VPC is a VPC that's created in one project but can be used by other projects, right? So that way I have less VPCs that I can manage and I can share them across multiple projects, right? So that's what they're showing here. So here they're saying I've created a shared VPC and I'm basically using that shared VPC in different projects, the recommendation project, the personalization project, and so on. Right? So this is very commonly done as well. Right? And VPC peering, what we just talked about, allows VMs on different VPCs to communicate with their internal IP address or private IP address. Right? Okay, so, and in fact, you can even peer VPCs across organizations because normally, like one customer, one organization, like, you know, Google.com or TCS.com, IBM.com, HCL.com is an organization. So imagine I'm a software as a service provider. Let's say I'm doing backups of your virtual machines, and I want that I want the communication between my network and your network to be as efficient as possible. I can peer my VPC in your VPC, even though we're in different organizations, right? And again, why is internal IP address communication more efficient, it's faster, it's cheaper, it's more secure. Okay, and again, there's a lab on your learning path. Again, we're not going to do it now. We're going to keep going that you can do on VPC peering. But if we compare shared VPC with VPC peering, the main thing is the motivation is different. With shared VPC, I can only do it within an organization. I can't do it across organizations, and I only really want to do it to centralize my network admin. With VPC network peering, I can do it across organizations, but I don't want to centralize networks. The two peered networks are still managed separately. Okay, so let's just pause there and we'll just see if there's any questions. Okay, yep. Okay, so let's continue on. And we talked about internal. So I've always got an internal IP address on a VM. I may have an external, right? And I can, normally my IP addresses are what's called ephemeral, which means they can be changed when I stop and start the instance. But I do have the option of a static IP address if I want to. And again, we saw how we could create the VM and choose what option we want for our IP addresses. And okay, so the next thing we're going to talk about is private Google access, right? So private Google access is, first of all, we have to understand the problem. How can instances without an external IP address access Google services or Google Cloud services, e.g. cloud storage? Now, the answer is private Google access, right? Because if we don't have private Google access, instances that do not have an external IP address will not be able to access services, right? So we need to configure private Google access. Now, fortunately, it's extremely simple to configure. But first of all, let's show you the effect of not having it, right? So again, if we just create so what I'm going to do here, I'll call this instance private. So this is only going to have a private IP address, right? So I'm going to go down here and basically I'm going to choose to create this instance without an external IP address. So under external IP address, I'm going to choose none, right? So I'll create that instance. And okay, so now I'm going to connect to that instance, gcloud compute SSH instance private zone US central 1-A. Right? So I'll just connect to that instance. Now, again, remember that instance has no external IP address, right? So if I try, so now I'm connected to it. If I try and list all my storage buckets, can't do it, right? Because I have not enabled private Google access, right? So what I need to do here is enable private Google access. So private Google access is enabled at a subnet level. So let's go into, sorry, just sure I'm in the right project. And basically I'm on the US Central subnet. So again, I'll choose that subnet, and you can see that if I click on edit here, I'm going to turn private Google access on. At the moment, it's off, right? So let's turn it on. As I said, it's very easy to configure private Google access. And once that's saved, we will then retest the... So now when we go back and have a look here, you'll see that private Google access is now turned on for that subnet, right? So now if I reconnect to that instance, and just do the same thing I was trying before. Okay, so now I can list all my storage buckets. So now I can access my Google services, right? So private Google access is necessary to configure if you want your instances without external IP addresses to be able to access Google services, right? Okay, so we saw how we could enable it and what the effect of it is. Now, there is an on-premises equivalent as well. Okay, so let me just pause there and see if there's any questions. If you want communication between different VPCs, you can do it. You can do it with peering VPCs across organizations, for example. You can also set up VPNs between VPCs. So there is a range of ways of doing it. Okay. So again, just VPC peering is one way. You can also create VPNs as well. But VPC peering is probably the most efficient way to do it if you want to streamline your communication. Okay, so we'll just keep going a little bit longer and then we'll take the break. So we've already talked about firewall rules and how they're made up, right? And we also have what are called implied firewall rules. So implied firewall rules are not actually explicit, right? So if I go and have a look at the firewall rules, if I go and have a look at my firewall rules here, there is no rule that says block all ingress, right? But that is an example of an implicit rule, right? There's no rule that explicitly says that, right? But that's an example of an implied rule, right? So that's the block all incoming connections unless I can find a rule to grant you access. Similarly, there's also a implied egress rule, which allows all outgoing communication unless it's been blocked, right? But again, they're not actual rules, they're implied, right? Okay, now we also have, when we create a default VPC, we also create default firewall rules. Now, these rules this is again just Google trying to make things easy for people by creating common rules automatically. So for example, allow SSH is so I can connect to my Linux instances. Allow RDP is so I can connect to my Windows instances. Allow ICMP is so I can allow ping traffic for network testing. But if, for example, you didn't have any Windows machines, you might want to delete that allow RDP rule, right? So you can delete those rules if they're not required. Right? Okay, so we saw how we could create the rules. And we can also choose which instances our rule should apply to in our VPC by either setting a network tag on the VM or identifying the virtual machine by service account. Again, we will talk about service accounts and we talk about IAM, right? But let's just accept for the moment that when we're creating a firewall rule, we can restrict which virtual machines on the subnet the firewall rule applies to, either by tagging the virtual machine with a network tag or by the service account that is the property of the virtual machine. Right? Okay, and generally speaking, it's seen as more secure to rely on service accounts rather than network tags. Okay, so you can read that there. And one more thing that I'll just show you before we break is there's also what is called a firewall policy, right? So normally we said a firewall rule, so don't confuse a rule with a policy, right? A rule is applied on the individual VPC within the individual project, right? But what about if I want to have a policy that says I'm always going to have the same firewall rule across all my projects, across all my folders, right? So what I can do in that scenario is create a policy, a firewall policy, and that will automatically be applied to all my folders or all my projects. I can either set the firewall policy at the org level, or I can set it at the folder level. Right? Now, I can only do this if I have an organization already set up, right? So if I just show you a little demo organization here, so you'll see if I go here, and I've got a little demo organization called Mango Mikey, and I've got the organization, I've got 2 folders, and within my prod folder, I've got 3 projects, right? So that's my organizational structure or my resource hierarchy. This is a very important concept in Google Cloud, which if you've done the fundamentals course, as I suggested, you will have been introduced to already, that org, folders, projects, resources. You've got that hierarchy, right? So if I go and have a look at, say, my firewall policies, so just remember that hierarchy. So I'm going to look now at firewall policies, not rules, right? So if I go into firewall policies, and you'll see if I go into my folder level, so I'll go into my prod folder, and you'll see what I've done is I've created a policy at that level, which and again, a policy is just a bunch of, is a container for one or more firewall rules. So I've created a policy at that folder level in prod. So now if I go and have a look at any project in that folder, like let's say analytics, you'll see that I've inherited from the folder level, I've inherited that firewall policy. Now, I can also create my own firewall rules as well as inherit firewall policies, right? But firewall policies are a way to get consistent firewall rules across multiple networks and projects within your organization, right? And this link here is just about a link to some short videos on different aspects of VPCs if you want to get that. Okay. Okay, so I think we will break there. Just let's see. Yes, network tags are specific to VMs. They're just a property between VMs, right? So when you create a VM, you have the option to add network tags to the VM, right? So you'll see that if let's just go to my demo project. So if I wanted to add a network tag here, for example, I could just click on edit, and if I scroll down here, you see here, if I say choose that, it automatically generates a network tag, right? Or I can add my own tag, right? And then I can refer to it in a firewall rule, right? So it's just a property of a VPC. Okay, so we're going to take the break now, and after the break, we will do the lab. So just grab yourself a tea or coffee, and we'll start again in 12 minutes. Thanks. To partner.cloud skills boost. If you're confused about temporary accounts and that, I would recommend First Lab. So that person who is confused about the temporary account, I think you should at least reread the First Lab, which I'll send you now, because they're really very basic concepts that you need to understand. So have a look at that tour of Google Hands-on Labs to understand what's happening. But basically, temporary accounts are just created for the duration of the lab. So I have no idea why you're trying to use it again, but it seems to me you haven't understood so have a look at that tour of Google Hands-on Labs. Okay, but for the rest of you, you can do the multiple VPC network lab, which again should take you around about 30 minutes, right? So let's just have a look at it. I mean, they're saying an hour and so, but generally they give you at least twice as long as the lab will take. So I think you should be able to complete this in about 30 to 30, well, let's say 10:45, which is a little bit over 30 minutes. So we'll review the lab then. Thanks.